Hi, everybody. Welcome back to our live stream. My name is Johannes Verwijnen. I'm the principal instructor at deepdives-eu. Got a pretty long background in development and machine learning, data analytics. And with me, as always, I have Mikko Nieminen.
Hello.
And we're going to be talking about generative AI today. So this is a topic picked by you, Mikko. Can you give me a little bit of background of what your interest is in Gen AI?
Everything, to be honest. I'm interested in where it came from, and so a little bit about the history, and then where we are now and where we are going. And I think I have a bunch of questions here waiting for you. So if you just get started, and I just keep asking you, hopefully
Sure.
not stupid questions, but you'll be the judge.
Sure. So a lot of the Gen AI models that are out there, kind of going history first, right, are based on large language models. And large language models are basically the current state of art for natural language processing, which is a specific field of AI. Right? In that field, we have many things. We have stuff like translating or transcribing audio into text, translating text between languages, and that kind of stuff. So this started already quite a while ago. I remember attending a course, or maybe just one lecture, on vector embedding, or text embedding into vectors, which brought, at that moment, like over 10 years ago, surprisingly nice results. And basically,
I'll just
that's
stop you right there. What is text embedding?
Yeah. So traditionally in machine learning, what we need to use as input data is structured data, right?
Mhm.
So we would have maybe we would try to predict somebody's salary, and as input data, we would have something like an age and your education level and where you live and that kind of stuff. And then based on that, the examples of those kinds using machine learning model, we would then be able to predict your salary based on those other pieces of data alone. Now,
Okay.
Thinking about text, that's a little bit difficult, because we can have text consists of words, and we can say the same things with putting words in a different order within a sentence. So a single sentence cannot be like one data point. So what we need to do instead of looking at these individual words plus their meaning in context, is we need to somehow create a version of those words that is better or easier for machine learning model to understand. And vectorization is, I think we have a Wikipedia page for word2vec. Yeah. So vectorization of words is basically what we do when we're preparing text for ingestion into a machine learning model. So instead of using the actual text, what we're doing is we're tokenizing words, and we're turning them into vectors. So basically a direction in an n-dimensional world, and then some kind of a distance as well. And this allows us to do interesting things. So once a vectorization algorithm starts to work, we can start to do vector math on it. And the way this was explained to me originally at the university was exactly this example here, right? So in this n-dimensional vector space, we would have a separate vector for a man and a woman, and a king and a queen. And now let's take the difference of the vectors between a man and a woman, right? We can do that in math. We can find what the difference is. That's another vector. And then if we add that vector to the king vector, we should get to the queen vector automatically. And this basically means that this solves one of the original problems that we had when we started with AI. Like I think for the first, well, not the first 10 years, but like in the 60s and 70s, quite a lot of time was spent in trying to get an AI to understand concepts. So we would create these hierarchies of concepts, like a king to a queen is the same thing as a man is to a woman, to be able to deduce context of things. But back then we did do that programmatically. So people would use literally their whole research life to create this kind of a hierarchy of words and concepts to put into an AI to then be able to reason based on.
And explicitly making those connections.
Yeah,
Like
exactly.
by person.
Those. Yeah. And now with word embeddings, this happens automatically. So if we just have a large enough corpus of text, we can create this kind of a vector model that
without people
without
trying
any
to make the
manual
connection. Yeah, exactly.
Yeah. So it kind of understands the context by just seeing repetitions of these words being used in specific uses, and then it kind of figures out the end outcome is basically this vector model where we can then do math. Okay, so once we have this vector model, even though it might be interesting, we're not actually doing any math, right? But this is how the large language model understands different concepts, and then understands the context in which we are asking it maybe to generate some text for us or to label something for us, right? So the language model itself is automatically created. And then that language model is then used to understand, first of all, what is required, and then to possibly also generate some answers. So this is kind of where we're coming from. And I remember some early work by Haba, Hannu Toivonen, again, over 10 years ago, where he made a machine learning model generate poems in Finnish. And he even had an art installation for that. So people would come to the installation and everybody would get a poem printed for them. That was generated by an AI. So back then, those models were still fairly small, not perfect, but it kind of has existed even prior to the modern kind of craze that we're right now. So I think if we look at history here, it talks about the general AI history, but then and then we're starting to see stuff like Markov chains. So this will then lead to RNNs later on, and then those would enable us to do stuff like autoencoding, and then GANs to kind of better the result of generating something. So maybe a little bit about the GAN. Kind of in layman's terms, what a GAN is that we have this generator of content, whatever, right? Here it looks to be an image. It could also be text. Think of it as being the poem, right? So we have a generator that just generates random poems. Then what we have is a discriminator. This discriminator has been trained on what poems are supposed to look like. So it'll give a score back to the generator for the poem that it has generated, and then that allows the generator to better the quality of its output without having to have a human being there manually again giving.
So they are competing with each other.
Yeah, and this is also how the Google Go AI was created, right? So traditionally, you could think of maybe a chess game is easier to think of. If you want to create an AI that can play chess, you can first give it like the rules to use when making moves. That will not help. You can try to make a search based on a tree of decisions that will somehow better your position if you have some kind of a good measure of how far you are. Or then you can actually make your machine learning model read through all of the played chess matches that we have transcripts for, right? So then it sees different kinds of patterns of how we can respond to things that have happened on the chessboard. But that still doesn't make it a very good chess player. The final moment for an AI to become a good player is when it can play against itself, because there's only that many chess matches ever played by humans, and it's fairly quick for an AI to play those chess games.
Do you know who's the best? Do you know who's the best chess player at the moment?
Is this still the Swede?
Norwegian, Magnus Carlsen.
Norwegian. Yeah.
Norwegian.
Magnus.
And he will lose against computers nowadays.
Yeah, probably not every match, but
yeah, but still, the computers are better than him, or the best chess engines are better than him.
Yeah, and then there are of course also always these kind of edge cases, like if we say that it's speed chess, something else in a smaller envelope, we can still probably get a human to win when kind of intuition makes a bigger has a bigger effect.
Yeah, that's actually interesting. This going beyond the, aside the topic, but is it going to be easier or harder for humans if you give limited time per move? And that's
it's an interesting question.
It could be other way around, that computers are even better when you have limited amount of time.
It depends on how it has been implemented. But yeah, so because like if you watched the Go World Champion, the big event back then, it actually took the AI fairly long to decide on what the next move is going to be.
Okay, and when was this? Like
AlphaGo. When was it?
But like recently or like years ago?
Years ago, yeah.
Years ago. Okay, yeah. So that has changed already. But let's get back to the actual topic, which was Gen AI.
Yeah. So this is kind of the background for Gen AIs. Kind of these were the previous kind of ideas on how to create an AI where we don't need to basically manually program the AI to understand concepts, but to let it learn those themselves and then use that to query it for something. That basically could just be playing a game. It could be labeling images, or it could be generating something like text or images or whatever. And the big thing that happened was a transformer. So kind of prior to transforming, a lot of this stuff used RNNs, where we basically look at one token, one of these vectors at a time, and then decide what to do next in this kind of a specific format. And where do we have the trainer? Here. This is what a transformer nowadays looks like.
Where does it
it
start? What is the input?
yeah, it doesn't really, tell you a lot, but you can see the input here on the bottom left-hand side. There's an embedding, so this will change
So what would be the
input text,
Okay.
for example. So we would be embedding the input into vectors, and then what we do is we use this attention function. It's called a multi-head attention function, and the idea with attention is actually the same as what we do when we're reading text. Right? If you're reading a sentence in a book, you're actually not reading every word. Your attention is focused on some words in that sentence. And this is something that we learn over time as we're reading more and more. We kind of faster readers because we can skip over stuff that we don't think to be that important. And that is what actually changed the whole world of natural language processing. So this attention allows the parallelization of reading through text. So previously it was done using an RNN, where we need to run each word or each vector through the whole network one by one pass at a time. That takes a lot of time. It's serial, it cannot be parallelized. Whereas with the attention method, we would actually be able to parallelize it. So that's why it's called a multi-head attention. So it's looking at several words simultaneously and then weighing those words depending on the context. And then that way, creating this, or being, that way, it's a lot faster to train the model, the language model than previously. And we're doing the same thing also for the output. And I don't want to go too much into detail regarding what the attention is, but
A question.
yeah.
You mentioned that when you're training a model, and let's focus on the large language models. How long does it take to train a model?
It depends on your model size.
Of course. So let's say doesn't you don't train it on your laptop, but if you're, let's say, talking about Bard or Chat GPT, how long does it take to train a model like that? Just to give to get an idea how enormous task that is.
Yeah, let's see if we get some number. Yeah, here are the numbers. So there are a couple of things here that affect the training time. First thing is the size of the model. So this is a neural network. So we say how many parameters. And with that, we mean how many weights there are in that network, right? Because each weight needs to be optimized. So if you look at early LLMs like GPT-1 from 2018, it had 117 million parameters. So a network with 117 million connections. And then whenever we are training for each example, we are basically updating all of those 117 million parameters. Or if we make a mistake when we're training, then we are updating those parameters. So that's kind of one thing, right? So that's one dimension in which we can grow, right? So BERT from Google then had 340 million parameters. The GPT-2 had 1.5 billion, GPT-3 175 billion, and so on and so on and so on, right? So now we're
and
at
what where are we
trillions.
now? Trillions.
Like the latest is 46.7 billion. There was something with trillions as well, but yeah, here this one by
something
Huawei.
Different. So what does it mean compared to the Chat GPT, the first version? And this was 2023, and that was only 5 years ago.
Yeah.
So is
So
our number of parameters, so it's different. Scroll down to the trillion part. What was the number of parameters there?
which one?
So that's already 1,000 times larger in 2 years.
Yeah.
1,000 times more.
Yeah, but as you can see, we're not really going any further than that, right? So the
So we
only
have reached. So what
yeah,
would
kind of
so
the
that's one
outlier here is
million times
GLAM.
larger.
Well, as you know
Can
from
you
machine
compare
learning,
them directly?
if
Are they
the
comparable numbers? So
bigger,
if it's 1 million times larger, is it 1 million times better? No.
well, no, in machine learning, the model complexity, then of course, kind of affect the probability of overfitting. So the more complex the model is, the more likely it is that we don't have enough data to set up all of those weights. So
It's just
basically
learning
that
the
leads
input.
to, yeah, that leads to overfitting, and then overfitting can be kind of characterized as being memorization. So then the model just remembers the correct answer instead of generalizing. Then it
Exactly.
will fail when seeing unseen data, right? But yeah, but we're kind of in the 100 billion range, roughly.
And that
Uh,
we came from in just, let's say, 5 years, we have 1,000 or million times larger models
yeah.
in some sense. So how long does it
Yeah.
take to train one?
Well,
Because
that depends on the other dimension as well, right?
okay, go ahead.
So training even the biggest model with just one data point, fairly fast, right? So the other thing is that how much data do you play through the model in training, right? So that's the corpus size here. So BERT was using 3.3 million words. It says here, we're sometimes saying tokens here, and in layman's terms, it's kind of the same thing: words or tokens.
So it's just text.
Yeah, it could be other things than text as well.
Yeah. Okay, but
For our
the
purposes,
3.3
let's say
billion
that
words
it's
is not like 3.3 billion English words, individual distinct English words, naturally, but it's just all the books and all the web pages and
yeah.
things like that.
So for GPT-2, we know that they used 40 gigs of data, so about 10 billion tokens. GPT-3, 300 billion tokens, and kind of as this number gets bigger, then the network number or the parameters number should get bigger as well, because otherwise we're doing underfitting, right? So we are having so much data that our network is not complex enough to be able to, find all of the differences between that data. So they kind of go hand in hand, even though there are different dimensions in which we're growing. So basically, kind of crudely thinking, the time it takes to train a model is dependent on both the training data set size and then the network size, and then probably also hyperparameters, what type of batching we do for training and so on. So now the problem is that these very large models, like 175 billion parameters, these do not fit onto the memory of your GPU, right? So we're, first of all, when we're doing neural network training, we're mostly doing that on a GPU because we need to do a lot of kind of backwards calculus stuff, which happens to be what GPUs do very well, because in 3D graphics, you need to do the same thing. So, and another thing that's great with GPUs is that the memory bandwidth to the graphics memory is really fast. So traditionally with neural networks, what we try to do is we try to fit the whole model, so all of the parameters of the model into the GPU memory. Then we don't need to talk to the main memory at all. We can just do all of the calculations locally over there and things run really, really, really quickly. Now, these models don't fit there. So what we need to do here is we need to actually split the model into multiple parts, and then different GPUs take care of each part, and then communicate with each other the intermediate results, so that that can continue. And this is a science of its own in kind of how to parallelize using model parallelization, parallelize the training of these. The outcome is that even with very, very large clusters of computers having the latest GPU on them, it still takes ages and costs millions for training of these models. Right? But I think that was the answer that you were looking for.
And the ages is give me something concrete. Is it days, weeks, months, years?
It depends on how much capacity you take, right? So these parallelize not linearly, but they parallelize quite nicely nowadays. And you can do both model and data parallelization simultaneously. So basically, the more hardware you throw at the problem, the quicker it gets done. Okay. Yeah. So on your computer, on what you're using right now, it's never going to be finished. But if you're putting enough hardware onto it, then it has the possibility of being done in a reasonable amount of time.
It's like a few months or
no, weeks or weeks. Even 1 week. Yeah, I think in reInvent, one of the keynotes, they were talking about one specific model that they were able to now. It was some company's specific large language model that they were now able to actually train in a week instead of several months previously.
And okay, just again a beginner question here. I'm not inventing these. I've really this comes from my heart. If you train a model like that takes, let's say it took you 2 weeks to train and it was really expensive. You had a ridiculous amount of data which you used to train it with. Okay. Then half a year later, your training data and the data that you want to use to train it with has increased. Do you start from scratch or do you just continue or how does it go from there?
So you can do additive, but both options are valid, right? So you can do additive training. So you basically just play the new data to the model and let it update the weights. That's done especially with very large corpuses. With LLMs themselves, there are actually multiple other ways to update the model, not actually requiring any retraining either. So the products that we are seeing, like ChatGPT, I think ChatGPT puts out a new version of the model every 3 months or every 4 months, or something like that. So that doesn't necessarily mean that they retrained the model. There might be something else. There might be some parameters that have changed. So it's still using the same language model, but then there is something else. There is some training going on with regards to which answers should be preferred over others, right?
And that's why that's why every now and then it asks, do you prefer this one or the previous answer? If you
yeah, and the original
ChatGPT,
yeah, so I think it's ChatGPT 3 here. Yeah, so this is the original kind of one that was good, right? Yeah, it's a decoder only transformer model, and the idea, this model actually came out fairly early, but it was not really usable at that moment. So what happened was that they used some reinforcement learning to be able to make the answers better. And what they had for that was human beings that would actually run through different kinds of questions with the model and then give them a score. And that's one of the things that we're doing a lot. So instead of totally retraining your model, if you would have the necessity to prefer certain types of answers, let's say that you would have a kind of a raw model, but then you would want to make some content that's suitable for kids. So you would need to remove all of the profanities from the output. So there are two ways to do that, right? Either you take away all of the profanities from the input, that way the language model doesn't know about it, but then you would need to retrain the whole model, right, from zero. Or you can just train the output part, right? So just kind of crudely thinking, put a filter in place that removes any answer that includes a profanity. But in reality, what we're doing is we're weighting the outputs differently. So
And not
you
only
can do
profanities,
that kind of adjustment.
you could be you probably want to avoid too complex words. You want to have a limited like set of
That
words
kind of
that you're
stuff.
using if the output is meant for younger people, or
Yeah.
if it's meant for people who are not, for example, fluent with in English.
Yeah.
Right, you could
Yeah.
use simpler English.
Yeah, exactly.
And the models actually work quite well when you are asking for something. You can ask, could you just rewrite that with using simpler terms and more simple words, and it works quite well.
Yeah, but that's I think that's kind of how large language models work, at least on a high level. Here you can actually see this is the
Can you zoom in a little bit?
multi-head attention visualization. So for each token in a set, we simultaneously calculate how important the other tokens are for the context, and then that gives the model the possibility to concentrate on what is really important in some text. And this basically made this training of these huge models possible. Like otherwise, it's still technically possible, but it would take really ages to work with this. Okay.
The changes were like Chat GPT was released a bit like 13 or 14 months ago.
Yeah, exactly.
The one
So
that really got popular. That
yeah, it was
received
launched November 30, 2022. So when we talk about GPT, the GPT model did exist before ChatGPT. So it's called the generative pre-trained transformer. So it's a transformer model. It didn't have a UI. And ChatGPT then kind of broke the bank by making this more approachable for persons. So it's GPT 3.5 or 4 nowadays that the ChatGPT implementation is
But
built
there
on.
were a few things that needed to happen for this to work. First of all, well, we had to have the science behind this, and then we also had to have enough horsepowers. We need to have lots of hardware, cheap
Yeah,
enough hardware, right?
yeah,
So it's not only about the science or the theory. We needed a lot of CPUs with or GPUs and lots of memory, and then the right moment. And of course, when everybody started to use them, or not everybody, but more and more people started to use them, then it became also profitable to retrain the models and all that. I'm not a business person, but it makes sense that if no one is using them, then it would be a bit of a waste of money to spend millions and millions of every month just for fun to retrain the model.
yeah. Another thing here is that it's not only the training that makes money; it's actually also the inference. So because this model is so big, then that even doing the inference, even just
Okay,
answering something.
so we've been only talking now about basically talking about the first half training the model, but then of course you get to use that. So how big is the model when it's been trained, it's ready, and I write a question to regardless of what the model is, I ask a question about something, then what happens
Okay, so
in
it kind of
general?
depends.
What happens in the background? I give input, I ask a question. When would it be nice to, where would it be nice to celebrate my birthday?
Yeah. So it depends on what type of language model we're talking about.
Let's
So
since you have Chat GPT there open,
yeah,
then
so ChatGPT is an autoregressive model, right? A language model. So what that means is that it basically only looks forward in the order of the tokens. And this is actually important when you're to understand when you're using a model. So right, so if you ask it something, it reads in your question one token at a time. And so the context is really important to come first, because it can't infer the context later on, right? So you need to be careful to put things into the correct order in the prompt. And then what it does is it tries to find, or it generates output, right? And the idea is that it tries to generate the most probable output regarding your input. And it does this generation also one token at a time. So that leads to some interesting hallucinations that you might see. But kind of this kind of goes together with prompt engineering. Prompt engineering is kind of how to ask questions from a large language model. And kind of the I guess the general gist is that first tell it what you want. Right? First tell it that.
so in my case, would it be that I want to celebrate my birthday, or what? What do you mean?
Yeah.
What do you want?
Um, I have a birthday on the next Saturday, next
Next
Tuesday,
Friday
Friday.
ish.
Okay. I have a birthday on next Friday. Give me the best options of places where I want to party, where I can party. Right? So you in the beginning tell it what to do, and then you can add information. And you can say like, I'm roughly X years old. My guests like these and these kind of things. This kind of food would be nice. This and this kind of drinks. But in general, the more stuff you have, the less interested the model is in what you're saying. So the important stuff needs to be there at the very beginning, and that's
Okay.
because we're kind of parsing the input one token at a time. And if we decide, you kind of think of it as being like a branching logic.
Mhm.
If we decide something on a early token, then we can't kind of go back anymore and
So I
change
have an
direction.
example here. So let's say I'm not. I have an event that I want to arrange, and if I say in the beginning I'm having a birthday party, so that's making a branching decision there. And the other option is that okay, unfortunately, there's a funeral that I need to arrange. So that's kind of a huge difference there. And if you make that in the beginning, then
Yeah.
kind of you
Then
understand
you make sure.
completely different end results.
Yeah, and that's the
So what
problem
would
with.
be a bad prompt then? Just to give you a counter example. Let's stick with
Well,
the birthday party.
yeah. So, what are nice restaurants in the area where I am currently? I wanted to pick it because I want to arrange a birthday party.
Okay, yeah, I got it. Yeah.
So it's going kind of, you're giving
So
it the chance to go the wrong way in the beginning.
if I describe my guests and my hobbies and my preferences in the beginning, and then at the end I say, "Oh, by the way, it's a birthday party or a
Yeah,
funeral or I
yeah.
don't know, a kid's birthday
And
party."
then you might still get answers, of course, but generally speaking, those answers should be worse than if you
I
would.
need to test this. I will test this.
There's another thing that you can do, which is kind of one-shot training. So as part of the prompt, after you have said what it is that you want, you give it examples of answers. And that helps the model to kind of concentrate on the right thing. And that's kind of how you can make ChatGPT even do math. So if you just ask it something, it doesn't really understand that. But if you give it examples of similar questions and their correct answers, then you're making it more likely for it to actually be able to.
So how, in general, how large can the prompt be then?
It depends on the model, right?
Naturally,
So with
let's stick
ChatGPT,
just. I don't want to favor ChatGPT here, but since we've been talking about that, like for
yeah,
a few
so we're
minutes now,
calling it the prompt size. Blah, 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 blah. I think it's something like 20,000.
and when you are asking additional questions, will the previous questions and the answers are part of the prompt, or
Yeah, so if
what's that
you
called then?
interact with ChatGPT, then yeah.
That's what I mean. Yeah.
Yes. So that's another way that you can. So another way to kind of one way to think about prompt engineering is like try to give the LLM or ChatGPT instructions on how to get to the correct answer. Like in your example, you could add like, okay, disregard any wine bars. You don't like wine.
Open to
Prefer
suggestions.
places that have foreign beers, and that way, if you kind of can break the problem down, either in the original prompt or like telling it how to reason through a math problem, or then by doing a secondary round, right? So kind of first giving it a partial question, and then it comes back with a result, and then tell it to further change the answer. So that by breaking your big problem into smaller problems, you make the possibility of a good answer coming higher.
Yeah. So I've been using like that, like secondary rounds.
Yeah, and another thing is to remember that it only looks forward, right? It generates the output one token at a time. So you can also try to affect it by telling it to first reason and then give the answer. That way, there was like an example of a math prompt where it was like asked whether some value is a prime number. And then it was specifically asked in the prompt to show the reasoning. And then in one version of ChatGPT, it actually answered first wrongly that no, this is not a prime number, but then it gave the reasoning that it actually is a prime number, right? And that's just, if you would have told it to reason first and then give the answer, it wouldn't have made that error, right? It's just because it answered immediately, it kind of just the first token went the wrong way. But then it actually showed that it's just text generation. There is no logic there. It doesn't know that it is reasoning.
Let's continue from that. So we have about 15 minutes left here. So what's the future? So I understand now when you ask something, it's not an entity that understands the answer itself. It's just generating. It's just math, right?
Yeah.
So how large should the model be so that it's self-aware, or how close we are to that?
Well, it can't be because it's just generating text one token at a time.
So what's the difference between that and your brain?
That's a good point. So actually, your brain is also generating text one token at a time. You might be making some pauses and then thinking about what you're going to say next, but the actual text output is just kind of one at a time. There's this discussion about math which is a little bit simpler than your question, which kind of
Mhm.
shows where we are. So the question basically from the math context is, does GPT have a world simulation? So does it basically
Has what?
a world simulation? Yeah.
Well,
So
yeah.
a world model. Think about that. So basically what that means is, does ChatGPT, when you're asking it a math question, understand that there are these numbers and that there are rules how to combine these numbers, and then do the result based on that? Or does it just look at examples and then figure out what the most probable answer is? Now, the thing here is that we don't know. And the other thing here is that we don't know if there's a difference. We don't know whether there is a difference in us having this kind of model of how the world works, and then reasoning based on that, is what we want to do, or whether the whole world actually is just probabilistic. So we're just seeing patterns and reacting to them, right? And that kind of shows you that where we are currently. So it's because of the size of the model, we can't go back inside to the parameters and see how ChatGPT is actually working, right? We can't see whether in those parameters it actually has created some kind of a limited model of the world that it then actually uses to reason, or whether it's just all statistics, or whether they are actually the same thing. So that's where we are.
The reason why I asked this is, uh, if you think of your brain just a simpler, in simpler terms, you have brain is just a bunch of neurons, right, which are connected with each other. And if you have a neural network on a computer, I don't see why the computer one will not be as large and complex as the human brain someday.
Yeah, but does that spontaneously give us?
But I don't see I don't think there's a difference there. Other people think otherwise, in different ways, but I think it's just a different medium. One works on silicon, and the other one is the brain tissue.
Yeah.
Just
So
chemical reactions, and but that's not about. This is a bit away from the topic of generative AI. But in general, I think that the computers will reach self awareness at some point.
so
You might
if
disagree.
it's just if it's just the number of neurons, then are some animals also self-aware?
But are they self-aware? It's
Yeah, that's my question.
hard to prove for simpler animals or entities. But is there something else with the Gen AI that we want to cover? We have about 12 minutes or so. Let's see.
Just going to show you
Uh,
this picture,
yep.
because humans have like 86 billion neurons in the brain, and then we are considering ourselves self-aware. So chimpanzees and gorillas are fairly close to us, but have clearly less neurons. And maybe we're thinking as them as not being as self-aware, or at least with smaller animals. But then we have things like elephants that have way more neurons
Maybe a
than
bit
us.
redundancy there as well.
Yeah, so it's not just the number of neurons. So self-awareness doesn't kind of spring out of complexity automatically. There needs to be something else there as well. So,
Mhm.
and that's kind of what makes the difference. So from a complexity point of view, of course, there are differences between neural networks and brain
But we
neurons.
could use human as a good kind of baseline. That if you have, what was it? It's so small I can see this 86 or
86.
68, 86 billion neurons.
Yeah.
Then if you have that amount of that in that order, the ballpark, then something could happen.
Yeah, GPT-4 Here we're talking about parameters. So these are basically connections between neurons. So it's a
Mhm.
different number, but you could try to average out things and then see how close GPT is. There's a rumor about GPT-4 having 1.76 trillion parameters, which could be like close to, or I don't know, but could be close to 80 billion neurons, and depending. But yeah, it's interesting. But yeah, so like I said, currently in the way that we're using the neural network is we're just pushing data through it. So there is like no spontaneous action. So right now it's just basically just statistics, and it's just really complicated statistics.
Really, yeah. Hey, here's another one. Uh, say something about the ethics of Gen AI.
Uh, the-
Is there something that we need to be aware of? Something that we need to kind of be careful with?
yeah, there are many things here. So one of the things that of course from an end user point of view changes with Gen AI is that now a machine can actually generate believable content, that being text, images, audio, whatever, right? So that's kind of one aspect of it. So we cannot trust that something has been generated by a human. And then the other part is the training data, right? So the output, the basic machine learning, right? If you output trash into the model or input trash into the model, then you will get trash as output as well. So what has been the corpus that has been used for training? I think GPT-1 was based on Reddit threads only and links outwards from Reddit. Some of the
See some
open source
problems there.
Yeah, some of the open source models are based on these data sets, like the English Wikipedia text, and then there's like an open source books text set as well. But it truly is interesting. So you kind of need to be aware of where the data comes from. Does it include data that you are agreeing with or not? And then on the other hand, does it use copyrighted works as input, right? So if something is on the internet, it doesn't necessarily mean that you're able to use them. And this has been actually used in reality as well. So I think New York Times asked its content to be removed from a large language model. I don't remember which one, but and that request was then complied with.
Yeah, and I can also see problems with if you are using generative AI to create some text which is more fact than fiction, then what if the model has been trained with fiction, like books, not like biographies, but like just
Yeah,
like
yeah,
fiction?
yeah.
It
It
might
can just
produce good text. It probably does produce good text, but by
you just
the
remember that
content.
there is no truth in the output, right?
Mm.
That GPT or generative AI models don't know whether they're telling the truth or not. They're
And
just
I
giving
can,
you the
yeah,
most probable sequence
they
of
give very
tokens.
plausible explanations and answers, but you really have to know the topic, and you really have to go through the answers. If you're complete beginner of a topic and ask for answers, you don't know that the answers are incorrect.
Exactly.
I've noticed that you
And,
really
and
have
one
to
of
be
the
careful with the output.
one of
If
the
you're
reasons
looking
for
for
that
facts, that is.
one of the reasons for that is that I think it's using greedy search when it is doing the text generation. So that means that it only selects the most probable next word in its output, one word at a time. And that's really problematic because the actual best answer could have a word like a lot of tokens ahead that would then
Yeah,
give you the best probability for the whole sentence. But ChatGPT can't do that because it's too complex as a model. It cannot search through except one.
And you can actually see that when, especially when it's the slow time of the day, or meaning that there are lots of users for ChatGPT, you can see that it's really slowly generating the output.
Yeah.
Like
and that's why it's important
a few
to
tokens
ask
at a time when it from the user interface point of view. But still, you can see that it's generating the text even slower than you can read. So you really have to wait.
And that's also why it's important to always tell it to kind of start by reasoning, so that it can generate the correct result by first doing the reasoning part. Yeah. Yeah, there's so much more to talk about here. Maybe we could do some separate videos on.
Maybe we take a more focused. We focus on one specific topic, subtopic here, and then.
But at least this should have been a nice intro into large language models. With natural language processing, a little bit of a look at behind the scenes, how things really work. But like 1 hour is definitely not enough to kind of go into specifics.
Yeah, it's scratching the surface. Okay, one more question. We have about just a couple of more minutes. Give us some ideas how businesses or individuals could use the models, not just like generate they're in the university and they need to write an essay and they just use ChatGPT or equivalent to answer, but something else. Is there something else that maybe not that popular yet, but a way to use these large language models?
So what they've been used for now is generating answers based on questions. And what they're doing then is they're adding like their own internal knowledge base to the corpus of the language model, and then that allows people to for example ask a question in natural language. Like for AWS, you could ask, how many CPUs does a M5 large have? And then it will be able to answer that in natural language, which then of course also helps with people who don't know how to write or read, because it could just as well do it via audio because it's natural language, not something specific. And this has been used quite a bit now, and it seems to be like the first proper use case, kind of making these knowledge bases more acceptable for a larger number of people.
Okay.
Then of course the law, the cases where people would try to look up some cases that really didn't happen.
Yeah, and I remember one of those. So probably we will see in the future. So all this happened from like the user's point of view in the past a bit more than a year, but of course a lot of things happened before that, so that we are at this point. Just like with your cellular phones, you just at one point in time you started to have mobile phones, but a lot of things happened before that which allowed you to have mobile phones and the networks and all that. So if we take a look into this in 5 years, we are probably going to see something that we don't even imagine today that we could have.
Yeah, and we didn't even have time to look at the autoencoder models. So maybe we need to kind of discuss that. What are the differences, and why would somebody use an autoencoder model instead of an auto regression?
And we didn't look at the image generator generating. Yeah, I'm a photographer, so I've been looking at those images as well. Some of them are really good, and some of them are hilarious.
So maybe you're going to host the image one, yeah?
Yeah, maybe that would be actually really very interesting.
All right.
I'll generate my favorite images first and then showcase them here.
Okay. So I think we
Thank
have
you,
to
Johannes,
stop.
for this. This is really informative.
No, thank you for putting me on the spot and making me try to
That's always
explain
my
this slide.
pleasure.
And yeah, for everybody who's listening, thanks a lot for being here. And we're going to continue next week. Did we have a topic?
We had a few we have a few options here, so
We'll create.
let's keep that a secret.
Yeah, for
I'm not
now.
sure what we're going to talk about yet next week.
All right, cool. Yeah, thanks for being here, and see you again next week. Till then.
All right. Bye-bye.